Hello, my name is Greg George from 3D Systems, and today I'd like to show our Geomagic Design X product and how to process this scan data from the Faro arm laser scanner inside of our product here that I have, Geomagic Design X. So before I start, I always like to just give a brief explanation of what Geomagic Design X is, and then go into some of the tools that we have available here. Geomagic Design X is a product that specializes in taking scan data from devices like the Faro arm here, where you connect directly to that device, scan inside of our product, and then we also have CAD tools in here to extract CAD model information and get them over into the CAD environment. So this product exists because people like to scan, or people want to scan actual objects and get them in the digital world. And most of the time they want to get them over to a CAD environment to recreate these objects or reverse engineer these objects. So what you see here on screen is an actual scan from a Faro arm. And what we're going to do is take this data here. You can see I have all these scans over here on the left-hand side, and we're going to process them together into one polygon mesh. And then we're going to model them, extract CAD information, and show how we can send that over to the CAD environment. So right away, as you see, I have 7 different scans here in the tree. Every time you pull the trigger on the Faro arm, it will record a separate scan, and I can right click on these and I can say show this one only, or show that one only, or I can just go back and show all of them. So you can see that I have them all here. First, we scan the table. So the first thing you might want to do is just come over to our polygons section here and just use some of our editing tools like windowing in and selecting. And you can see I turned off the eyeball there, so I can actually select through. I can just use the selection tool to be able to window in and select through all the polygons that are there. And for people that don't know, just as a brief explanation, if I zoom in here and turn on the edges and then just show one, you'll see that a polygon is essentially a point cloud of vertices, but they're connected together into triangles. So you can see it forms this surface mesh. And in this instance, every time, again, we pull the trigger, we have multiples of those. So you can see those are the edges of the triangle objects or polygon objects. So what we normally would do is we'd come in and we would, I always like to run a best fit alignment between all these just to make sure that they fit together really well and nothing moved while it was scanning. And then I like to run a merge. I like to run a global remesh, a decimate, and I use all those tools over and over again repetitively on projects like this. But over the course of doing that for many years, we've created a lot of tools to help automate that process. So what I'm going to do is I'm going to take one of those tools that we've used to automate that process and use it here today. So see these scan processes here? If I come into the scan process designer, what we've done is we've taken a lot of the scan processing tools that I talked about here, where I would want to merge these together and then change the resolution and all those things. You can actually take and create a little script that will run automatically on this data. So what I've done here is I've built one specifically for Faro data to where you can dictate that you want to run a alignment, a merge with the proper settings, and decimate it down to a certain size, and so on. So what I did is I took and created that, and you can actually export these and import these into your software. So I'm going to say run my scan process. I'm going to say use the Faro data. And for today's demonstration, I'm going to tell it to go ahead and remove the original data and just give me the output information. And I'll just select all information and tell it to go ahead and run that script. So just like I said, down here at the bottom, you can see that it's doing a global alignment between all the data. It went ahead and did a merge. Now it's decimating all of the scans down, and then it will automatically run a region group, which I'll talk about here in a second, but region grouping will go ahead and group triangles together into common curvature areas or flat areas or cylindrical areas or extrusion areas. So it's almost there. I think it's done now. So now you can see the different colors like we were talking about here. Once their regions are here, you can actually edit those. I don't usually do tons of editing with these, but just to show some of the steps. If I come in and I grab the line tool, if I want to break up these two sections, I can create a selection there and hit insert, and it will break up those two areas and then make a new one in between. So if I want to grab this area here and then say insert, and with these small areas here, if I want to merge those all together into one big green area, I can. So I can come in with the rectangle selection tool and hold shift and grab all these regions and say merge together. So you see that it merged those together. And same thing over here, you can come in and you see here that this is broken up. For future modeling, I'm going to go ahead and break up some of these little areas because I know what I'm going to do here when I model this. So I'll go ahead and break that up, create a new region there. So all these are, and you'll see here in a little bit, are just helper tools to allow me to quickly select areas and work with them. So let's transition out of regions and go into some basic scan editing. So I did some deleting and things like that, but I can come in here and window in and do a lot more than that. So with this select by custom region area, I can automatically select things like holes there. And if I wanted to remove that area and fill it in all in one step, I can actually come over to what we call a D feature. So I can select that area and then have the software fill in the missing information. So obviously, if the software is doing that, then it's able to do hole filling and different things like that. So you can see how it created that missing information there. And the same thing goes for these little holes on the side. If I wanted to fill those holes, I'll just go ahead and do a quick save here and come over to hole fill. I can select all those bounded areas and just tell the software, go ahead and fill all these small areas. And then hit OK. So now it's going to make up all the missing information in those areas. Obviously, ideally, you might want to scan all those areas and make sure you have data coverage all around the part, but it's not necessary that you have to scan every single area in order to model it, because you can either ignore that area when you're modeling, or you can fill the holes like I just did. Some other really neat tools are this Smart Brush tool. So if you have some chatter or rippling of the data, you can come in and you can do kind of Photoshop type stuff where I can use the Smart Brush and smooth and decimate and relax. There's all the different types of algorithms here that you can apply to this information. And it works really well on ragged edges like that. You can come in and you can very aggressively smooth out edges of things. And if you see here, I can just I can relax that area. So there's lots of different things you can do within the scan data editing phase. You saw that I deleted, I filled holes, you can defeature areas, you can enhance the shape. And then one final thing that I like to do before I start modeling on this information is the ability to run the Healing Wizard. So the Healing Wizard will look at the mesh for common problems that we typically see when you're scanning, and then we automatically repair those things, all these different categories. We repair those on the scan data, and that just allows you to have less issues when you're trying to extract surfaces from the mesh or solids. So that just makes it a lot easier to work with. Now, after I finish this, you'll notice that the first thing, if I turn on the reference planes for the entire world here, the part is kind of floating off in space there, right? It's not aligned to the CAD coordinate system. If you want to model this, It's a lot easier if I model this if it's aligned to the CAD coordinate system first, right? So what I'm going to do today is I'll just use some of our tools to extract some of the information here to create planes and things like that to go ahead and align this object together. So to start, this part is semi-symmetrical. So what I'm going to do is I'm going to go ahead and come over and create a reference plane. And we can actually extract a mirror plane or a, you see here, mirror or a symmetry plane. But in order to do that, what you have to do is you have to give it a good starting point. So if I just draw a general plane of where that plane is, where that plane ideally should be, and then I select both the mesh and that plane and tell it to generate a mirror plane, and then hit calculate, the software will actually calculate the most ideal mirror plane down the middle there. So you see that's really interesting how you're able to calculate that. Now I'm going to go ahead and use these top cylindrical areas to create a cylinder vector from a cylinder axis. So I can extract a vector from a cylinder axis. And if I come in and I'm just going to select manually some areas here on the top surface, making sure that I only grab areas that are forming that common cylinder between these top areas, making sure that I have enough good data that it will calculate a very good cylinder axis between those areas. And now I hit OK, you'll see that it calculates a center line right down the middle there. So once I have those data, those reference entities or reference geometry created, I'm going to go ahead and turn on my regions, and I'm just going to look at that top plane and make sure that's good. I'm going to use that top region to do my alignment. So now that I have that, I come over to this tool called Interactive Alignment. The first step, it asks what mesh that you want to move. So I'm just going to say we're going to use that mesh. Now for this XYZ type of alignment, what it's asking for is what is the origin of that coordinate system that we create. And what I can do is I can select multiple entities to form that. So what I'm saying is I'm going to intersect that vector with that plane to create a position between those two. And you see how it snaps that origin to that. Now what you can do is you can say I want my directional axes to align to other things. So I can say I want to align maybe the z-axis to that same symmetry plane. And then I can say I want to make that y-axis align to that top region. So you see I've placed my coordinate system right in the center of this part. So the idea here is the concept is just that you have the ability to create an alignment between the object and the whole world coordinate system. That way you can effectively align these objects and model them in a good CAD coordinate system, and it makes it very easy. So from here, now we can go ahead and start the modeling process and extracting model information from this part. So I'll go ahead and start with these top ears here. And what I'm going to do is just select that center plane and create what we call a mesh sketch through that data that's there. And we'll create those top mounts for this part. You notice I have the ability to do a regular sketch or a mesh sketch. And the idea is the mesh sketch will reference the scan data while you're in the sketch mode. And you have the ability to use that data as you're sketching. So you see this pink line here. I have the ability to window in and best fit data there. I can draw a line and snap it to that data. And then you see here, if I just exaggerate the best fit, if I window in a little bit of data from there and there, it's actually best fitting a line between that selected area. So all the tools that you use for sketching have those abilities of snapping and creating geometry here. So I'm worried about this top ear. And what we have is this ability to create a slot like any other CAD package. But the thing that's really interesting about creating the slot is I can window in all of that, and the software will create that slot automatically for me by best fitting. So if I undo that, I can also apply a dimension. So if I just say this has to be 7.55, and then I can even add like a center line down the middle, and I can add dimensions to that. I can actually make that point fixed. So that way when I drag it and change the angle, I can even apply another center line straight down with vertical constraint to it. And then I can select those two lines and even apply, let's make this 15.5. So I can dimension everything about this slot here and create a nice, accurate sketch of exactly what it should be. So now when I get out of that sketch, you can see where the sketch is aligned to the scan data, and then I can come over and then create a mid-plane extrusion. You see I'm best fitting originally to that data there, and then I can dictate, okay, this needs to be a 16 millimeter extrusion, and then hit OK. So there, we just manually created a CAD solid over top of the data that's there. Now, if I want to go from the other direction and cut those slots through, I'll do those here in a second. But before we do that, I have the ability to also, let's create this other ear here on the left-hand side. I have the ability to take and automatically extract geometry from the scan data as well. So if I come over to what we call our wizards, I have an extrusion wizard, which I can come over and select the outer shape of that extrusion area. And then I can tell the software that it needs to put the sketch on that CAD face there. And then we'll just tell it to insert another solid there. And just tell it needs to extrude up to that plane. And then hit next. It automatically draws and extrudes that for me. And then when I hit OK, you see that it created that on the side there. Now, it didn't create that internal cutout, and I didn't actually create that internal cutout here. So I'm just going to stop for a second. If I click on that original extrude and go to that original mesh, you see here that I can right click on the sketch, go normal to, and everything is history based. So I can come back afterwards and I can go ahead and create that circle. Now let's just make this a 2.5 millimeter and then get out of the extrusion. And there you go. You see that it updated. Now the same thing goes for this as well. If I click on this extrusion, it will locate it in the tree for me. I can go to the sketch that created it. It's right above it. Go normal to. You see that it has this other internal circle and a couple lines that are associated with it. So if I just come over here and do the same thing that I just did before, draw my circle, maybe draw a couple lines. I could even mirror that if I wanted to. Obviously, that's the way I would normally do it, but just for the sake of time, I'll just draw it as is. So I just updated what I extracted automatically, and you'll see that we created that. And then I can merge those together in a second. And let's go ahead and create those cuts through the side. I also have the ability when I do a mesh sketch to turn on the silhouette tool, which will allow me to basically form a box, and it will shine a silhouette to that plane and allow me to use that whole silhouette to sketch. So if I turn that on, I can see where those slots are. And again, I'm just going to do this very quickly. But if I just come in and I can snap this to the data, and I can dimension it and create exactly what I think these should be. And you can make these collinear and all that if you want to. So I'm just going to draw those two and then turn on my solid. And then I could go ahead and do an extrude from the midplane, both directions, with a cut to it. And it will cut those away. So you see that we've modeled what's there so far. So now I've showed some of the basic modeling tools. For the rest of this, there's some more advanced tools that are really helpful to model this. These side planes, as I looked at it, they appear like they are drafted, but there are some variations. So that's not drafted. These two might be drafted. This is clearly not a draft. That's more of a loft. So I can extract planes and surfaces and stuff automatically using these same wizards. So flat surfaces obviously are pretty easy compared to what we've been doing so far. So if I say I want to extract some flat planes, I can go ahead. In this instance, I'm just going to make the decision that all of those need to be extracted except for that front one as flat surfaces. And there's my preview, and then hit OK. And I'll just turn on my CAD surfaces. So it extracted flat CAD surfaces for all of those. Now all I have left is that side. So I'll go ahead and turn off my surfaces. And what I'm going to do is select that top region, like we talked about before. And I'm going to tell it that I want to create a plane that's offset. So I'm just going to offset it down a little bit, and I'm just going to find a spot where that radius kind of breaks. And I'll just create a CAD surface reference plane there. And I'll do the same thing on this side. I'll just preview up, and I'll just go up far enough that I get some good data. And then create a plane there. So there's a ton of different ways of extracting this surface. Some of them do a very good job. It just depends on the kind of input data that we're dealing with. What I'm going to do is manually loft it, but you do have the ability to select that data and do what we call a mesh fit. And you could wrap a CAD surface around that. And if I just hide all the others, you'll see. But if you see how it wrapped that around, I'm not happy with how it fits exactly. So what I'm going to do is go ahead and take those two planes and show how you can do some advanced modeling with those. So I'm just going to cut a cross section through there. And I'm going to go ahead and draw a spline manually through here. So if you're familiar with doing lofts in any CAD package, you'll know that splines are the key to doing very good, clean lofts. And then as usual, when I'm done drawing a loft, I always like drawing a spline. I always like to come back, edit the amount of knots that it takes to create that, and I can even tell it to evenly space those. So now it's got 15 knots in that spline. And the reason why I do that is if I draw my other cross section, I want it to have a nice clean 15 as well. And then when it creates the loft between the two, it's a nice smooth transition throughout the cross section. So if I come over here and do the same thing on this side, and then go ahead and hide my mesh, I just like to draw it this direction. I can come over to that same spline tool, and I like to overdraw my splines to make sure that the CAD surface is extended far enough to trim to the surrounding CAD surfaces. So that's why I'm taking that approach. And you'll see that this is like tipped up a little bit, so let me just pull that down. And then do exactly what I did before, where I selected that and then say 15 evenly spaced. Now, if I take those two sketches, I have that top one and the bottom one, I can tell it to do a surface loft between the two, and it creates a nice clean surface loft. Now, when I turn on all the other surfaces, with the exception of that mesh fit, it doesn't quite extend as far as I need it to. So I can come over to the modeling tab and do a surface extend. If I click on the entire surface, it'll extend in all directions. Or if I want to manually do it on just the two sides, I can click on the edge and it'll extrude just those two sides. So now you see that I've created a nice intersecting surfaces all the way around. Now we have a tool, like most CAD packages do, that allows you to take, if all these surfaces that create one bounded shape, it will combine them together into a solid. So if I come over to Surface, Solidify, and select all of these guys, and then hit OK, you'll see it disappears because it created a solid. And there we've created a solid by intersecting all of those surfaces together. And then obviously there are fillets on there, so we need to come in. Now if I select an edge and I hit this estimate from radius, what it'll do is it'll look at the underlying mesh and calculate what it thinks the radius of the mesh is. And then you have the ability to come in and override it, which is usually what we do, right? Override it to a nice nominal number. And then you'll see that I'll go ahead and apply the fillet all the way around. And then go ahead and take those other CAD bodies, because I left them as separate bodies, and we'll just Boolean everything together to create one solid. So there's my mesh. I'll turn off the regions just to make it a little easier to see, and turn on my CAD. So that's one approach to modeling this. And then once you're done, you can check the accuracy and check the deviation from the body. So I made some decisions as to how I was going to model this. If I went ahead and created a surface loft or a scan fit, it would fit exactly to that surface. But what I wanted to do is create a nice clean transition. So there's going to be some deviation here because I decided to deviate from what the scan was. But overall, this tool, deviation from body, it gives you feedback to let you know how accurately you're modeling it to the original scan data, and you can make decisions as to whether or not you want that or not. And this is really just a feedback tool to let you know how closely you're following that mesh. So once you have that, you can then take this CAD model and you can live transfer this and send it over to SolidWorks. So I'll go ahead and just turn off some of my planes here and the scan data, and then we will come over to the live transfer tool. What this tool does is it will take everything that I've built inside of our history tree and build those same entities over inside of a CAD package. And you see that today I'm going to use SolidWorks, but we can send it over to Creo, Inventor, NX, AutoCAD, Solid Edge. And send those things over. I can send over the whole history tree like I'm going to do today, or I can resume from the selected feature. So if I want to send over small pieces or even selected entities, I can do so. So I'm going to hit start from first feature, and it goes ahead and opens SolidWorks. And then it again starts from the top feature and goes and builds everything one at a time over inside of the CAD environment. And you'll see that happen here in a second. So when it finishes, it leaves everything showing. So I always like to keep these tools available of just hiding all planes and hiding all surfaces. I like to be able to turn those off very quickly. But you'll see that it sent this everything over and it built it all at once over in here inside of SolidWorks without me even having to do anything. It just built every single thing every step of the way. And then if I just come over and click on, for example, that first original extrusion that I did and hit Edit Sketch, go normal 2, you'll notice that that dimension and the constraints and construction geometry that I created inside of Design X are here as well. So everything comes across, whether it's parallelism, tangency, dimensions, whether it's fixed, all those constraints and dimensions come across into the SolidWorks environment. And then from here, any SolidWorks user will be able to work with it. And most SolidWorks users would never even know that this originally came from the Geomagic Design X product. So that's an overview of the entire workflow from taking a scan data set, doing some cleanup work, aligning it, and then modeling it inside of Design X.